So the first thing I would like to discuss is what is Redis for the people who don't know anything about Redis.
Uh, so basically, Redis is mostly popular in our industry as a cache. People use it specifically for caching use cases, and Redis is known mostly for it. But just by introduction, Redis is a database, in-memory database. Redis specifically stands for Remote Dictionary Server. If some people don't know, basically it hosts just it's a way of thinking that it hosts a lot of data structures for you.
Okay, yeah. Yeah, but most people know it as a cache, and most of the times you will see people comparing it with Memcached and all that. But I've seen that Redis has a lot of other use cases. So it's not just simply being a cache. It is sometimes used in streaming applications, sometimes used as a database also.
Exactly. So, like when like the Redis has been evolved in such a way, like Redis has evolved into like a ton of data structures. Redis like it performs everything in memory. So, people think that like you in a typical architecture, what you have is you have your application and you have a database. So, a database is basically you want persistent in a database. With persistence come kick in the data that you retrieve frequently will be comparatively slower, so you want frequently access data, which is not being updated very frequently, and basically it can be as well. If there is a way you can retrieve this data faster, Redis provides you this way that you can retrieve this information from memory. Redis comes up with like as you mentioned it. Some people use it in for streaming application. People use it for it as a primary database as well. How? Because we can just think of it like that. Redis does have basically Redis streams as well. Redis does have key value store. Redis does have hyperlog logs. It does have PubSub. Basically, ton of use cases. Based on these use cases, we want to evaluate whether like for which use case you want to actually use Redis for, right? Okay. And for example, for evaluation, I think if you want to compare it specifically whether or not like Redis is like what Redis is meant for, and we can evaluate it on specific parameters, right? Okay. And I think we can hop into like just to know what Redis is and how we can actually evaluate like Redis against whether or not it can be a primary database or not.
Yeah, yeah. So mostly to say like it is kind. Most of these applications these are available like in a form of code, which is written in a certain way and handles memory in a certain way, and then maybe we can just deploy it to our use cases like how we want to deploy it. So how you have seen like Redis being deployed and like the how are the so for example what will you first do to maybe set up a Redis cluster or like if you get the Redis source code like how do you use it?
Okay, so just think of it like that. So, for example, you have this. You have this client. Consider it as app or web client communicating with your basically your server. You have your database, the SQL or a NoSQL database. Basically you want fast retrieval. For let's just take a simple example. Now you want to introduce because you want fast retrieval, you just came to know that Redis is something that giving you this option to like quickly retrieve. Redis is an open source, so you can take out the code and host it yourself. Just that Redis does have some modules that is licensed. Even if it's licensed, just that you cannot make business out of it. Just that you can self host anyway. So you took out Redis. Basically, you can host it in two ways. First, cluster mode, and and second one is a single node mode. We'll deep dive into what you exactly need. Okay. So basically, Redis, the way you come, so you come again. You start the Redis cluster. You deployed in a bare metal instance, and you followed the steps that are required to host the Redis instance. Right. Basically, we can start with how do you connect with Redis, and then we can come upon what kind of architecture you want to use for Redis, right? Redis uses for most of the typical databases they use TCP. For some of the databases, people are using HTTP as well because you have like with HTTP you have free TLS security. Most of the databases because you will be connected throughout your lifecycle.
Throughout the time, yeah.
Basically, we need a persistent connection. Connection has already been built. When the application starts up, you start communicating with the whenever you require to retrieve and send events. So the specification of Redis is that specifically on TCP, the message format for Redis is RESP, which is known as Redis serialization protocol. RESP is the message format basically. You will communicate with Redis, and it is internal to Redis. like most of the databases have their internal implementation over TCP. Specific to Redis, they are you can just compare it as protocol buffers. They have exposed that they are using Redis. Some of the databases don't even expose it that what kind of REST format is.
Yeah. Someone can build their own format also, which is serialized and deserialized. Yeah. Yeah, but it is one question which came into my mind is like, do we always need to maintain a persistent TCP connection with Redis? Like, it is possible, right? Like when we have to fetch, then only we create the connection, and it is not created at all times. But maybe Redis has to create a TCP persistent connection with a database at all times. Maybe.
We'll jump into that. Basically, this Redis service has been started up. You maintain a pool of basically you maintain a pool. So I'll talk about why it's actually needed, and we'll obviously discuss about that. So basically, you maintain this connection to communicate with Redis, and it start like you maintain the connection. Let's say you are using a Go application or Node.js or Java. Like talking about popular packages, Node.js you have like Redis, Java you have Redis. Use this client to maintain a persistent connection. Finally, they have implemented everything that are required to maintain this connection. Okay, you are done. You hosted the Redis instance. It's a black box till now. It's a cluster or a single node. Let's consider it as black box. And you connected with the client, install the client. You connected from your application right now. Okay. So now we need to decide what we want to host. Whether it's a cluster, you want a cluster mode or a single node. So in cluster mode and single node is that you have only one primary and you can have multiple secondaries. Basically, Redis is going to connect, this client is going to connect with one primary, and it will not, for example, you can vertically scale this instance, but you cannot have multiple primaries.
Yeah. So this kind of like master slave architecture.
Exactly. It's a master slave architecture.
Yeah. So we have, but while reading also we can connect to the other replicas, or then also we have to just contact the master one.
So you can do that. You can upload your read queries to secondaries. There is also a configuration that you can make is you can pass it as secondary preferred. Whenever you pass a write query, it will go to primary. Read query go to secondary. You need to take care of, for example, if it's a very very near real time application,
then you will use primary.
Exactly. You have a requirement at the end of the day. You do a lot of batch processing over all of your caches. You can prefer secondary because the cache has already been there. It's a Redis term for cluster mode is that it's a cluster. Cluster is basically a bunch of nodes. It's a cluster, but cluster mode is basically different. That if you deploy Redis in cluster mode, that means you have multiple primaries, and this primary can have their own secondaries. So whenever your basically your Go Redis or this Redis client, for example, you just have to pass one primary endpoint. With that primary endpoint internally provides all of these basically primary IPs, primary node IPs. If it's self-hosted solution, you don't have a generic primary endpoint. So this particular, you can just pass a single IP internally. Identifies all the primary nodes from a single node. So they are connected. Basically, they do a lot of heartbeat mechanism in between. They know each other, what are secondary, what is primary. Okay. So they exactly know which IP to send. Well, basically, what are all the IPs.
Okay. Yeah. So why do we like have a need for multiple primaries if you are connecting with just one at a time?
Okay, so I think that's a very good question, and I think we'll explore the world of what cluster mode is, because single node is very simple. You just have a node. For cluster mode, specifically why cluster mode is needed. So we'll discuss the anatomy of a command, but specifically Redis revolves around this single-threaded event loop architecture. Okay, so Redis is bound to this single thread, so a single node can execute a certain number of commands at a specific point of time. Throughput is limited for a particular node. So Redis has been built in such a way you can basically distribute a load among multiple primaries. It's not just that we are connecting to a single node. No, not at all. So this is primary 1 and this is primary 2, P2, and this is primary 3, and they are connected among each other. I'm not drawing the secondaries right now. We'll jump into it. The architecture is built in such a way. So we call it hash slots. So what are hash slots? For a single node, there are no, like, we can just ignore this hash slot concept. Specifically for cluster modes, hash slot concept is very, very important when it comes to this architecture. Why? Hash slot is the way, so basically whenever you have like multiple primaries, Redis assign hash slots to these primaries. Number of hash slots that Redis does have is 16,384 hash slots. Logical slots. Say we have 3 nodes, right? So let's say we have like 5k hash slots assigned to each of these primary nodes. So how Redis works is, so whenever you fire a command, let's say we have a set command, set name equal to Sukhat. Redis computes this hash of this key and decides which slot should it be assigned. For example, this name got a hash slot as 7284. The Redis is going to send this command to be executed on P2. For example, there is another command called edge. Then the key is edge. So for example, we got the hash slot as 11,384. Command goes to P3.
Okay. So it is decided on the basis of commands. What hash slot will that command go to?
Exactly. So how basically we'll talk about how this scales. The client is aware of, every node is aware of its hash slots. So basically all of these commands, it's just a wrapper over algorithmic sharding. Shards based on hash slots. So for example, you add another node. If you add another node, now these logical slots has to be divided among these 4 shards. We have 4,000 hash slots per node. All of these primaries has to give up 1,000 hash slots to this node, right? Because you have to rebalance. So how do you transfer this data? So all of these, basically whenever you introduce another primary shard, so Redis does very intelligently, it intelligently assigns all of these the remaining slots in such a way the data transfer is minimal. For example, now the hash slot has moved to P3. This hash slot, let's say 7,284 moved to P3. So now whenever you send the same, for example, you do a get name. So get name, whenever you fire this command get name, it is going to be landed on P3 instead of P2.
Okay. So these number of hash slots, like you discussed, 16,384, these are fixed, and this distribution keeps on happening on the basis of number of nodes we keep on adding, number of primary nodes.
Exactly. So we need to, so basically it's a way of thinking consistent hashing. Logical slots, right? We discussed that, these are these hash slots, right? So now it comes with a lot of complexity. So for example, Redis does have something called a pipeline. So one more thing, specifically to client, right? So initially we discussed about this client from a specific IP with a single IP, it internally figures out all of the shards attached to this particular cluster. Why I told that? Because if you read the documentation, there is something called a slot refresh interval. So you have a client. This client is connected to this primary and it knows there are 3 nodes. And you added another node. Now the client needs to be aware of that, hey, I need to send this particular command to this particular primary. You can set this slot interval. So for example, every 5 seconds it's check, is there any relation? Your client is aware of that, hey, these many slots are there and it has been distributed across these nodes.
Yeah. So, but like we discussed, the client has the IP of one primary node only. So when it makes the call has to go on that particular node, right? And from there it will get to the different node.
Exactly. What I'm saying is ki from this particular IP, if you pass one IP, it internally figures out basically
to which actual
for that particular node, right? So particular node gives you all the IP addresses of all the nodes connected to this particular node. So client does have information about these many nodes are there. Just by connecting to a single node in a cluster, it is aware that these many nodes are there. Okay, the client is aware from this particular IP.
Okay. So now in this clustered solution, if we take an example of caching, suppose. So now writes are happening through multiple primaries according to the data which is there. Now the read replicas for each primary which are there, do they contain all the same data, or that is also determined using hash to which read replica the call has to go?
Okay, so the way it works is, so you have a primary, you have these primaries, and each does have 2 replicas. Whenever you fire this command, let's say set name x, right? So it goes to the primary, right? So based on the persistent level, basically this secondary, this publishes these commands to secondaries as well. So you have AOF, basically append only file. So from this AOF, it's just replay of commands. It fires off whenever it receives a write command. It basically sends these events to secondaries to write among themselves. So for example, whenever you fire a get command, you pass it to secondary. It just goes to one of the available secondaries. That's it.
If one of the slot fails, so the data has to be retransferred into the other nodes.
What do you mean by fail?
For example, let's suppose P2 fails. So the data which was present in that slot would have to be redivided into P1 and P3.
So you mean while moving, while setting this data, it fails.
No, in general, like the cluster is on and so for some reason P2 fails.
So basically, that's the way to think about all of these commands that map to this particular P2 will fail because
Okay.
this will just kick in the election. So one of the read replica will become primary.
Okay.
One of its read replica become primary. Until that point of time, your read queries won't fail, right? Your write will fail.
Yeah. But like if the complete cluster fails, I think that's very improbable though. But
You can have multiple, you can deploy these primaries can be in different data centers as well. Basically, for in a single zone, they can be in different data center because they are logically separated, but you have to divide it in such a way just that downtime is minimal. Why? Because you have slots divided among primaries. So even if one entire, like one part of Redis cluster fails, you still have like 8,000 possibilities of slots that are available for you to take right.
yeah, so in that case, for example, let's suppose the complete P2 slot fails. So in that case, the data which was there in that will have to be transferred to other slots, right? P1 and P3.
So fail basically if you delete this P2, P2 has to be transferred. But if it just fails, it won't, because it has to be up and it has to be like basically it won't occur because basically if it's down, that's fine. If you delete, that's a different case altogether. We can discuss about this that like why I have started with 3 primaries, because if you have like two primaries and you have basically you have even number of nodes. For example, you have like 6 nodes. For example, you have like this odd number of nodes, right? For example, you have like six nodes. Okay, so we always need to maintain an order, like odd number of nodes. So otherwise, you will end up in a split brain problem. Like for example, you have like even number of nodes, and so you have like you got divided in a network partition. So now this half is not aware what's happening in this half. Relation will be like you will have conflict because there is no decider. Odd even in an odd even architecture, you have like in the first one, right? You have like 9 nodes, and even if it's logically separated, you in one side you will have majority of the nodes. For example, 5, 4. The decision has to be like who will be the master, who will be the slave is like not conflicting.
Now, like we discussed about how the data is arranged in a cluster or in a single node. So, like if we go into the internals, like what makes Redis suitable for a cache, like how it actually stores the data internally on the disk, that makes it fast.
I have seen people have misconception that disk is actually used as a storing mechanism. Redis does not store. We'll just remove this NVMe's. NVMe is basically the SSD store of Redis. It's a new offering from Redis that you can store data in Redis in SSDs. And just excluding that from the conversation, Redis is actually in-memory store. So persistent can be enabled in 2 ways. Can be achieved in 2 ways. The first one is AOF, append only file. It's a standard practice. So you push everything, the command in a log file, and you commit it. Once it is committed, you acknowledge the client that, hey, your command is committed, right? And the second one is RDB, Redis database. Basically, RDB, we'll discuss both of these, what they actually do. The persistent can be enabled. So by AOF is basically you append into a log. For RDB files, so every Redis, the primary process, right? The main process. So it actually forks out secondary processes, like child processes in a specific interval. Okay. And it takes a snapshot of the memory and stores it in disk. So basically what RDB does is every time it forks out a child process. Why child process? Why cannot the main process itself? So you don't want to block the writes while doing the snapshot. Right? So it forks a child process. So what this child process does is, so you have everything in memory, right? So you take a snapshot, but you don't exactly, every time you don't copy whatever the entire memory into disk. It does what it does, it just checks a diff. So it takes a snapshot. It's just okay, what has been changed. Not do the entire snapshot.
Yeah. So in memory also, like what data structure it uses to store the data.
For example, you come up with a key value pair or list, right? For example, you have a list. So you maintain this list in Redis. Also, people come up with what is the difference that if I can to maintain this list in your in memory in your application itself. So what is happening is list is just an array, right? Redis provides you that hey, it's a central place. You can store a host list in Redis, and you can just like push, pop, everything you can do via list. Just an array data structure, right? So this is a way of thinking it that like Redis internally, whenever you initialize a list, it internally creates an array for you, okay? And you push, pop everything from the list. I'm taking an example of list. Just that it happening in a global level, right? For example, you cannot maintain this memory in your application side every time, isn't it? For example, for a particular API, you are writing an API in a particular, you have a specific context for that API. All of these APIs to basically, for example, there is an API which push something into the list, and it has to be global level. It has to be aggregated somewhere. You have to maintain that. People say like, where should we use data structure and algorithms in my day-to-day job? I was thinking like you are using, but it's internally using this. You're just making use of that, right? For example, sorted set. So, for example, you maintain a heap in your application. I'm just telling you, let's say B tree. Okay. If you take an example of a B tree, so every time you push something, it has to be rebalanced, right? So this is happening at a global level. It is aggregated at a global level only. So that this tree is maintained in memory. Okay. And every time you push something, it is getting rebalanced for you. But in memory, what you have to do is every time you have to construct this tree. You don't have to do that. It has been constructed in memory by Redis. So these are these data structure as it is. So for example, list is just a simple array in Redis only. For example, it's a getter setter is just a object has been initialized for you in memory.
So when it is connected to databases, for example, SQL database or NoSQL database, so how are they stored? Are they like for a SQL database, is it stored in a form of a B tree in Redis, or in Redis it will be stored in a form of the relational forms like normal rows?
But SQL pay everything in a disk, basically entire, we can call it heap. So the data is stored in pages inside disk. Disk is basically, we can call it heap. Inside heap, you have pages.
Yeah.
So whenever you store something, it gets stored inside a page. We are not considering the indexes right now. Indexes are stored in form of B tree in memory and also drop-in replacement in table as well.
But I'm saying like, for example, between client and this SQL database, we have a Redis cache in between.
So for example, you have a user information. You fetch from Redis. If there is a cache mesh, you go to database, pulls out the information. Either you can do is you return it and just cache. You return to the client, then you cache it in Redis. But the second way is while writing data, either you can do is you do it in a synchronous way. So either you write it in data. Basically, you go to the database whenever you write something for write queries. You go to the database, writes it, and actually like asynchronously you have to make a transaction. Basically, you have to make it transactional so that, for example, database writes is successful. You have to actually cache it in Redis as well.
Yeah, wait for that to also to complete.
Yeah, but one of the ways people achieve this is CDC as well. People do use this. These are you don't need CDC a lot of time. For example, every time there is a change in a database, you stream it, and actually that ensures that it gets populated to the cache as well.
Yeah. So any changes in the database are written to the cache. So but I'm asking like, what will be the format of data stored in Redis in this case?
Exactly. I'll tell you. So, for example, it's you have a table, you have a JSON information. Usually, we communicate in JSON. You have, let's say, you have ID, this format, right? We're talking about name and age. Let's say this is a JSON, and Redis, everything. If you want to store it in a hash or you have JSON modules as well, and before that, people stored it in a string format. So it is stringified and stored in a key. For example, it's a user info. User info is the key name. UID. User info is the key name. Basically, UID is the actual UID. User info is the basically to identify this is the unique key. Okay. So the value would be the stringified version of the JSON.
Yeah. So for now considering like we use Redis as a database, so the persistent part you talked about, do we use it in that way only? Like when we have to use Redis as a database, or we can use it in as an in-memory database also?
Okay, so depends on the use cases. Why? Because if you want drop-in replacement of your database, as of now, just looking at a lot of basically this disk is not exactly used as a storing mechanism, right? When Redis gets down, it's just going from AOF. It's going to actually like replay those commands and actually
Reconstruct the Redis. Yeah.
memory is limited anyway. So if you want a drop-in replacement, I still feel for specific use cases, just for caching use case, I feel you can cache specific information. That's why it's a cache. But we'll discuss about the different data structure that is the basically we can judge this on specific parameter. We can discuss about that, how it can be a drop-in replacement or not. We can discuss about that. I think we can start actually whenever you actually come up with a tool. Like every tool is basically a magic. Initially when you think read about something, it feels like it's magic, but you appreciate it, then you actually go inside and see how is this magic is happening, right? So basically if we can judge upon these parameters, like ACID properties. Whenever you see a database, even if it's a ACID compliant or not, even if it doesn't support ACID, these parameters will help you, or also concurrency primitives. These parameters will help you actually know that how, where your database actually, where this data store, where it stands, right? So if we talk about atomicity, right? So every command in Redis is an atomic operation. The transactions is also atomic. We'll discuss about the data structure of the use cases. So every command that you fire is an atomic operation in Redis. Okay. So we'll specifically talk about isolation as well. Isolation is like, for example, you can start transaction. We haven't jumped into the data structures, and it can be unrelated. Just that whenever you start a transaction, right, it uses the highest form of isolation. It's a serializable isolation. That means every transaction is sequential. Okay. So you can watch. Basically, there's a command called watch. So you can watch during a transaction. You can watch that particular key. So for example, you started a transaction. It uses optimistic concurrency control. Just that it starts a transaction, but it does not lock that particular field. Someone can write that particular key as well. In a series of transaction, you are doing a lot of writes in that particular transaction. For someone change that particular value while you are doing the transaction, it will fail the transaction at the end. There are two transactions happening, both will be sequential. For consistency I still feel for primaries, if you are actually moving to secondaries, it's eventual because it takes time to populate across. And durability, we discussed AOF and RDB files. So basically you can, whenever it's up, it can replay all of these commands to basically reconstruct all of its data structures.
For how long can we store these files, AOF files?
Depends on your storage. But for example, if you have 8 GB RAM, even if that AOF has 12 GB of commands, right? You cannot replay 12 GB of commands. So basically, Redis is limited by memory. So you need to take a decision. What do you want to actually store inside memory, right? So we can specifically talk about data structure because currently we're just talking about caching use cases, right? So people can actually think it's more than a database. Why? It is key value store. You have list, you have hash sets, right? And we can discuss about all the other use cases that Redis comes up with, which actually the usual databases doesn't have.
Yeah, sure. Yeah, let's jump into that then directly. Like, what other use cases can Redis support apart from just being a cache?